Hello, all. Welcome to the lecture series in applied chemistry, spectroscopy. In the spectroscopy lecture series, we'll here discuss about electromagnetic radiations. So, electromagnetic radiation is the basis of spectroscopy because all the spectroscopic techniques involves electromagnetic radiations. So, now what is spectroscopy? Spectroscopy is the study of absorption and emission of electromagnetic radiation when they interact with the matter. So the matter means any chemical substance. When we pass an electromagnetic radiation through a substance or a molecule or any type of chemical setup, it may be a powder, liquid, or in a gaseous form. So this electromagnetic radiation can interact with those materials, and there may be an absorption of some energy or there is an emission of certain things. So based on this, we can analyze the nature of the compound. So the spectroscopy is a technique to understand the character and the structure of a compound. Then what is electromagnetic radiation? Here we discuss about electromagnetic radiation. So what is electromagnetic radiation? It's an energy transmitted through space where an electrical and magnetic field, they are perpendicular to each other. When the electrical field traveling in this direction, magnetic field traveling in this direction, that is, both are oscillating perpendicular to each other in the direction. You see here, uh, in one direction, that is along the x-axis, there is an magnetic field oscillating, and along the y-axis, the electrical field is oscillating. So EMR means electromagnetic radiation. They exhibit a dual nature, uh, which is explained by de Broglie. So we know that de Broglie is a person who explained the dual character of any particle or things. So the electromagnetic radiation also has some dual characters. It has a wave-like character and a particle-like character. The wave-like character is explained by the interference, diffraction, etc. And the particle-like character is explained by photoelectric effects and photons characters. So the electromagnetic radiation. So what are the examples of electromagnetic radiation? So we can see that electromagnetic radiation from my left side to right side, there is increasing in frequency. That means we know that here we showing the wavelength. That is, a wave have a crest that is moving upward, and trough it is downwards. So the distance between the two crests or two trough is called as wavelength. We call it as lambda. And when the wavelength is short, we call it a short wavelength. And the wavelength is large, we call it as a longer wavelength radiation. And the wavelength and frequencies are directly proportional. We know that, inversely proportional, which means that when the wavelength is large, the frequency is less, and the frequency is large, then wavelength is. They both are indirectly related to each other. So it is inversely proportional to each other. So see here, when the wavelength is more, the frequency is less. When the wavelength is less, frequency is more. That means gamma ray, X-ray, ultraviolet, visible, infrared, microwave, radio wave, all these waves are the examples of electromagnetic radiation. So when you ask what is electromagnetic radiation, we can define and give an example. So all these seven is found to be an electromagnetic radiation, in which the radio waves have a longer wavelength and the gamma rays have a shorter wavelength. In the other way, we can say that gamma rays have very less frequency and radio waves have a larger frequency. And between the ultraviolet and the infrared, there is a visible radiation. We call it as VIBGYOR, that is 7 colors. And based on the gamma rays, X-rays, X-ray have X-rays have X-ray spectroscopy, and ultraviolet has a UV spectroscopy, and visible have visible spectroscopy technique, infrared ray spectroscopy, radio wave, Raman. There are a lot of spectroscopic techniques based on this electromagnetic radiations. And this is the classification of this electromagnetic radiation based on the wavelength, particularly UV, visible, infrared has been classified here. You see the visible radiation, it is between 400 to 800 nanometers. It is given in nanometers, the 400 to 800. And less than 400, that is 100 to 400, it is ultraviolet region. And above 800, it is infrared region. So based on this, we can see that the ultraviolet spectroscopy is available, where in which the wavelength ranges from 100 to 400. And infrared radiation, the wavelength ranges from 800 nanometer and above. And in between the visible spectroscopy, we have 400 to 800 nanometers. So what are the applications of electromagnetic radiation? As we said that radio waves, microwave, infrared, visible light, UV, X-ray, gamma ray, all these are electromagnetic radiation. All these have a common character that they travel in an empty space. They do not require any medium. And the electromagnetic radiations, all the electromagnetic radiation travel in the velocity of light. So radio wave, we know that it is involved in communication and TV, telecasting, etc. Microwaves are involved in cooking and radar devices. Infrared, this remote control, the remote control which we are using in our home, and some night vision cameras that involves infrared radiation. Visible light is the light which is available from the sun, and it is used for the photosynthesis by plants, and the human, we have a vision of over the visible light. Because infra, I, UV and all, we can't able to sense with our normal eyes. So UV rays, that is used for sterilization, and it helps to generate vitamin D in our body. And X-rays, we know that it's used in medical imaging. X-rays, when the bone fracture, and a lot of things we do with X-rays. And gamma rays for cancer treatment, and particularly for nuclear reactions. So based on this electromagnetic radiation, a sample can be analyzed. A source, light source can be different. That is based on that is based on this. When you use a ultraviolet lamp, which provides wavelength to 400, it is ultraviolet spectroscopy. When we use a lamp between 400 to 800, which gives a visible radiation, it is visible spectroscopy, and the same for infrared spectroscopy. So the source of light will be there, and there is a lens and grating material which converts some monochromatic radiations to polychromatic radiations to monochromatic radiations, and it pass through the sample. The sample has some interactions, either it have an absorption or it has some emission, and based on that, the detector will be there to detect the outcoming light through the sample, and the detector will sense and compare the intensity of the radiation with the source and the thing observed from the sample, and based on the difference, value or peak has been obtained. So based on that, we can study the special character of the compounds. So in this session, we have discussed about what is a spectroscopy, or what is an electromagnetic radiation, and characters of electromagnetic radiation based on the frequency and wavelength. And particularly, we discussed the wavelength in nanometer for ultraviolet, visible, and IR, and applications of electromagnetic radiation. And in the next session, we discuss about ultraviolet spectroscopy based on this block diagram. Thank you.